All right, today's lesson is I can multiply, divide, and add and subtract rational numbers. So in other words, we're doing operations with rational numbers. Now, the first one we're going to look at when we're talking about rational numbers is we're going to talk about integers specifically. Okay, remember integers do belong to the rational number set. So let's look at the first one. Now, you've seen these for a while now. And what I find very confusing is the fact that there's so many brackets that really are doing nothing, and there's so many other signs. So some of the stuff is actually just useless and actually is more confusing for our brain. So what we're going to do every time we see something like that is we're going to replace all the double signs with one sign. Okay, so anytime there's double signs right beside each other, so for instance, if I look here, there are two signs right beside each other. So I want to replace those. Okay, also, do I really need to put a positive 2, a plus 2 here to represent a positive 2? No, I don't. So at the beginning, I really don't need a bracket around this. I can just put the number 2. So I'm going to replace the double signs with one sign. Well, that's fine, but exactly what sign do I replace them with? Well, if the signs are the same, such as they are here when I have two positive signs, or if I have two negative signs, so if the signs are identical, if they're the same and they're right beside each other, we're always going to replace it with one positive sign. Okay. Now, if the signs are different, in other words, if one of them's negative and one is positive, then I'm going to replace it with a negative sign. So it's very similar to when when you're multiplying and dividing integers. You know that two negatives make a positive, or a negative times a positive equals a negative. So very similar. But this time, even though we're adding and subtracting, what we're doing here is if the signs are right beside each other, I'm going to replace it using this concept. So let's take a look, and we're going to get rid of the first. So as I said, I don't need the plus in front of the 2, so I'm going to put a positive 2, and I'm going to replace the double signs with one positive 3. Now when you look at that, you can see visually it looks very, very different. It's much easier for your brain to see 2 plus 3 as it is for it to see plus 2 bracket plus bracket positive 3 close the bracket. Okay, so we don't need that. So the first step, replace the signs. Now do the math. So 2 plus 3, you better know that's 5. All right, let's do another one. Okay, again, I'm just going to have the negative 3. I have two signs beside each other, double signs. Both of them are positive, so I'm going to replace it with one positive sign, so positive 5. So now what I'm left with is negative 3 plus 5. Okay, so you can either use the number line, or you should be able to do that in your head. I could actually go 5 take away 3 means the same thing. So I can see that I have two positives left over, so I have a positive 2. Moving on to the next questions. So let's take a look at number 3. Again, I don't need the positive in front of the 4. I can just write 4. I have a negative and a positive, so my signs are different, so I'm going to replace it with a negative 6. 4 take away 6, I'm left with a negative 2. Again, here I don't need the bracket around the negative 6. I can just put negative 6. Two signs beside each other, they are different, therefore I replace it with a negative 5. Sorry, a negative 5 actually, and that's what that should say. So we're going to get rid of that, so it should be a negative 5. And then negative 6 minus 5 is negative 11. All right, so that's adding and subtracting with integers. Now what happens when we're doing adding and subtracting with fractions? Okay, fractions also are rational numbers. But what's different about here, you must, and I can't underline this enough, you must have common denominators. In other words, the bottom numbers must be the same. Okay, you just can't add the top and add the bottom together. The bottom numbers have to be equal to each other. So let's look at the first question. And so this is review, remember, too, that I'm working on here. So you've seen this before. So I have 1/3 plus 2/5. Well, my denominators are 3 and 5. They are not the same. So I can't just add the top and the bottom together. I must make the bottom numbers the same. So how can I divide these so that they would be equally divided? Well, if I do this, if I multiply the 3 by a 5, that should work. And if I multiply the 5 by a 3, that will work, right? Because then I would have 15 on the bottom here and 15 on the bottom here. But I can't just do something to the bottom. I would have to do the exact same thing to the top. So if I multiply the bottom by 5, I must multiply the top by 5. The same is true here. If I multiply the bottom by 3, I must multiply the top by 3. And then my next step is 1 times 5, which is 5, plus 2 times 3, which is 6. On the bottom, I have, in both cases, I have 15. Now what I can do is I keep the 15 on the bottom and I can add the numerators. So 5 plus 6 is 11. Okay, and that is in reduced lowest forms. Okay, I don't want you to change it to a decimal. It needs to be as a fraction. Okay, the next one. This one I have 3 fractions together. I have a 3, a 4, and a 5. So first of all, I have to find something that all 3 of them will go evenly into. Now, you could try 12 doesn't work. It would be for the 3 and 4, but not for the 5. I think what I could choose is I could choose the number 60. So if I multiply so that everything has a denominator of 60, well, how many times does 3 go into 60? Well, it goes 20 times. So I'm going to multiply this whole fraction by 20. How many times does 4 go into 60? Well, it goes 15 times. So I'm going to multiply the top and bottom of this fraction by 15. And lastly, the 1/5. 5 goes into 60 12 times. So I'm going to multiply this whole fraction top and bottom by 12. All right, so 3 times 20 is 60, 4 times 15 is 60, and 5 times 12 is 60. So there is my common denominator. So now I need to multiply the numerators by those numbers. So 2 times 20 is going to be 40, minus a 3 times 15, which is negative 45, and I'm going to add a 12. Now what I'm going to do is I'm going to keep the 60 on the bottom, and I'm just going to add the numerator numbers together. Okay, at this stage of the game, I don't care how you get the answer. Pull out your calculator if you need to. But when you do that, you actually get, we have a negative 5 plus a 12, so we have a 7. All right, now one more question like this. Okay, this time what we have is a 3 plus 2 minus a half. Now you can see that the first two numbers are whole numbers. However, I can write them as fractions, and the way I can do that is I can put them both over 1. When I put them both over 1, they are now all in fractional form. So what's a common denominator between 1 and 2? Well, obviously the number 2. So my common denominator is going to be 2. And now when I look at the top, if I multiplied the denominator by 2, I must multiply the denominator at the top by 2. So I would have 6. And the same thing here, 2 times 2 is 4. And lastly, I have my minus 1. Okay, so I keep my bottom 2, and 6 plus 4 is 10, minus 1 is a 9. Now, although this is an improper fraction, it is reduced into lowest terms. In high school, we often leave it as an improper reduced form. Okay, so in other words, I want you to keep it as an improper fraction. It's more useful to us in this form. Okay, now also for those of you that have a fraction button on your calculator, there also is a review video on how to use your calculator with fractions. Okay, so make sure you check that out as well. You're welcome to use the fraction button in your calculator. However, I still would need to see some work, but at least that would give you some help if you needed some help with the fractions. All right, what we're going to do next is we're going to have one whole page yet to do slides. So I'm going to stop the video and create a new one for this slide.